number 5 on this challenge problem section. Guys, here you can see that what we have here is an implicit function because x's and y's are all together, and we are not going to even try to eliminate or isolate, or for that matter try to write y explicitly as a function of x. It may not be impossible to do that, but guys, that is still a lot of work, and then doing the derivation or finding the derivative that way is going to take us more time. Rather, what we're going to do is we realize that this is an implicit function, so we're going to use the implicit differentiation technique to try to evaluate the derivative of y with respect to x. Guys, we know the few steps or few things that one needs to know in order to use the implicit differentiation. One is we start by applying derivative on both sides, and then we also have to use the idea of the chain rule, keeping in mind that y is in turn a function of x. So guys, keeping those things in mind, we'll start by applying the derivative on both sides, and then we'll try to evaluate the derivative of y with respect to x. Guys, before I start doing it, so when I found this problem, it was again a challenge problem, but it was on a multiple choice test, so it had like 4 options and we had to choose one out of those options. Guys, when I did this problem and I got my final answer, then I looked at the 4 multiple choice options and I could not see my option, the one that I had that I got. Then I went back and I rechecked my work. Again, I could not find any mistake in my work, and I still wanted to stick with the answer that I had. Again, I looked at the options and they were still not there. So then I kind of went back and looked at my initial given equation, and from that I got a clue. Oh, I could use this piece, and so that I can transform my answer to the one of those options on the multiple choice test. So guys, sometimes if you are working on a multiple choice test, it can be a little tricky sometimes to kind of choose the right option, even if you did all the work correctly and you have a right answer, but then one may have to transform that to the answer or to the option that you see in the multiple choice test. So by itself, this may not be such a challenge or such a complicated problem, but guys, being on a multiple choice test and then not seeing that option, the answer that I got, kind of made it more like a challenging problem. So I wanted to share this with you. So let us start by actually applying the derivative on both sides. If I apply the derivative on both sides, this is going to be 2 to the power x ln of 2, right? That is how you write the derivative of the exponential functions, right? Let me quickly remind you. So we know the derivative of a to the power x is, or usually we use the standard form has b to the power x. So let me keep it as b to the power x is what? It's just b to the power x times ln of b. So that's what I'm using here on the left hand side as well as on the right hand side. So 2 to the power ln of 2 plus, guys, here 2 to the power y ln of 2. But guys, here I cannot just stop right here because we know y is in turn a function of x. So we got to multiply by the derivative of the y, which is dy over dx. Then guys, moving on to the right hand side, the derivative of this whole function, again we can treat this as b to the power whole x. So if it is like b to the power x, where b is a constant, we can write the derivative as 2 to the power x plus y first, then times the ln of 2, right, using this basics rule. But again, we cannot just stop right here. We got to multiply by the derivative d over dx of the inner, and inner in this case is going to be whatever is in the exponent, which is x plus y. This is again a problem where one should try to write all the steps. Guys, moving on. In all of these terms, I can see ln of 2, ln of 2, and ln of 2. So I can divide both sides by ln of 2. If we divide both sides by ln of 2, obviously the ln of 2 and ln of 2 is going to cross out both from the left hand side and from the right hand side. And let's see what are we left with. We are left with 2 to the power x plus 2 to the power y. And instead of using dy over dx notation, let me use y prime. And then I'm using y prime only here because I don't have too much space. So I'm just trying to save some space here. It's up to you which form you want to use. I, guys, usually prefer dy over dx, especially when I'm working with implicit functions, or especially when I'm working with functions which require a lot of extra work, so I don't want to make any mistakes. But this is not too complex, so we can work with y primes now. But I started with dy over dx, and then I sometimes like to go back to y prime. So then let us look at the right hand side. I have 2x plus y. Guys, we got to work with this derivative of these two. Again, these are 2, so we got to basically break it into 2 pieces. What is the derivative of x with respect to x? It is just 1. We don't have to do some extra work on that. And then guys, y, we don't have an explicit formula for the y, so we're just going to write this as dy over dx. And since we know dy over dx is y prime, so I want to be consistent here since I changed it to y prime here. So I'm going to put a y prime here as well. Guys, at this step, we have already applied the derivative on both the sides. We have executed that step. All we need to do now is we want to isolate y primes or bring y primes together to one side and have everything else, whatever we are left with, to the other side, and solve for y prime, which is basically solving for the derivative of y with respect to x. Let's see how we can accomplish that. Well, what we can do here is we can distribute this, right? We can distribute this first, so it's 2 to the power x plus 2 to the power y, and then I have my y prime equals to, let us distribute that, it's going to be 2 to the power x plus y, right? And then I also have plus y prime, or 2 to the power x plus y times my y prime. So let us focus on this particular equation. Looking at this equation, I can see that here I have my y prime, and then again here as well. So I'm going to bring the y primes together. What I'm going to do is I'm going to basically bring this term to the left hand side, and then I will bring this 2 to the power x to the right hand side. So if I do that, I'm going to subtract this, and I'm going to subtract this from both sides. So finally I will get this 2 to the power y times y prime minus, well, there's a y prime here, and then there's a 2 to the power x plus y, right? That is my left hand side now, and the right hand side I'll have 2 to the power x plus y minus 2 to the power x. Right, from here guys, I have to isolate y prime. That's what I want to evaluate. So what I'm going to do is, very easily I can see that I can pull out y prime as a common factor, not a greatest common factor, because if I want to take out the greatest common factor, I will have some other terms as well. Guys, keep in mind, whenever we are working with the, or using the implicit differentiation technique, and at the end when we are trying to solve for dy over dx, even if we have some other terms that we could pull out, but we only like to pull out the y prime because we're only interested in finding the y prime, okay? So then let us see what is left inside the parentheses. It's just 2 to the power y minus 2 to the power x plus y, which is basically whatever is left here with the y prime and here y prime, okay? When I multiply this, I should get back that, and I am going to get it back. Guys, this equals to whatever is on the right hand side. We don't want to try to simplify anything on the right hand side. Now this equation right here, I got to solve for y prime. Well, I know I have to divide both sides by this quantity so that I can get y prime by itself. So I think I need to get rid of some stuff here. So what I'm going to do is, guys, I'm going to get rid of this here. We already probably took notes on that, or it's already in the video, so you can see that. Guys, from here, what I'm going to do is, from this, I'm going to take it up right here. So y prime is going to be, when I divide both sides by 2y minus this whole quantity, so this will cross out on the left hand side, and on the right hand side I get 2x plus y minus 2 to the power x divided by what do I have in the denominator? 2 to the power y minus 2 to the power x plus y. Guys, this is the answer that I got when I was doing it myself without actually looking at the 4 options, because as I told you, it was a multiple choice test. So I looked at this, and then I looked at my answers. Again, it did not match up with any of the options. Then I looked back, I checked my work, I still had the same thing. Guys, then I realized that this quantity 2 to the power x plus y, I already have it. 2 to the x plus y is 2x to the power x plus 2 to the power y. It was already provided to me as an equation. So then what I did was I went back and I replaced this 2 to the power x plus y with 2 to the power x plus 2 to the power y, because it was already provided to me. And then there was this minus 2 to the power x divided by 2 to the power y. Again, there was a 2 to the power x plus y occurring in the denominator, so I just replaced it with this initial equation, 2 to the power x plus 2 to the power y. So then simplifying further, guys, 2 to the power x and this will cross out. I'm left with just 2 to the power y downstairs, and when I distribute this negative with both terms, well, both of them will have a negative. what's going to happen to 2 to the y and 2 to the power negative 2 just going to cross out. I was only left with negative 2 to the power x. And then, since we don't like to keep the negatives in the denominator, the final answer is 2 to the power y, but there's a negative up in the front, and 2 to the power x. And this was the final option, and this was the correct option on the four out of 4 options that I saw on the multiple choice test. So guys, actually, when I got this and I didn't see that answer on the multiple choice, I went back, I checked my work, but then I looked at my options carefully, and I realized that in my options, well, I'm not writing all the options here, but I see most of the options had just 2 to the power x and 2 combinations of 2 to the power x and 2 to the power y. So that also kind of gave me a clue that somehow I have to get rid of this 2 to the power x plus y, this whole quantity. So then I went back and started actually looking at the original equation and realized that, hey, I could just substitute wherever I see 2 to the power x plus y in my final answer, I could substitute those two with whatever is on the left hand side, which I did, and finally I got the right answer. So guys, what I'm trying to say here is that sometimes if you are working or doing these things for a multiple choice test where you have 4 options or 5 options, whatever the case may be, you should, once you get the answer, then you should look at, you should spend some time looking at the options and see if the options give you some hints about what you may have to do in order to get your answer transformed into a particular option that you see in the list of the options. Okay, so guys, this is example 5. I will see you next time with another challenging problem. Guys, till then, keep practicing, and if you have any questions, feel free to reach out to me. Take care.